Hello and good morning. We now move to lecture 2, which just deals with applications of integration. Okay, so we're now on applications of integration. We have done techniques of integration and we are now expert at integration. We should be able to recognize what technique to use when given a problem to integrate. Okay, so the first thing that we do under this is look at definite integrals. Okay, so definite. Okay, so we have always looked at a case such as this, maybe the integral of 2x with respect to x. Now, for definite integrals, we put limits, say from 1 to 2, the integral from 1 to 2 of 2x dx. So if we have such a case, then this is known as a definite integral. So how do we solve definite integrals? So the difference with how you solve definite integrals just comes in after you have integrated. Let's have an example. We should find the integral from 1 to 3 of x squared with respect to x. Okay, so this looks like one of the standard or important results. If we have such a case, then we know that we just have to add a 1 and this power, the new power, you divide it there. So then we have x to the power 2 plus 1 gives us a 3 over 3 plus a constant. Okay, so this was going to be our final answer. But because we have limits, we now put our limits. We put them. So what we're going to do is replace wherever there is x. We first replace with 3, then subtract and replace with 1. So this gives us, where there is x, we replace with 3. 3 to the power 3 over 3 plus c, okay, minus, now we replace with 1 to the power 3 over 3 plus c. Okay, so that is what happens to the limits. We replace them with x. Okay, we replace x with the limits. Yeah. So actually, let's just look at the next one. That just gives us 3 to the power 3. Remember the laws of indices? 3 to the power 3 over 3 plus c. So this is just the same as what? You have the same base. This is raised to the power 1. So this is a 3 to the power 3 minus 1. It gives you 3 to the power 2, which is just a 9. So therefore we have 9 plus 9 plus c, okay, minus 1 over 3 plus c. Now what happens if we break these brackets? We have 9 plus c minus 1 over 3 minus c. So you have plus c minus c. So these will cancel. Gives you a 0. So you just have 9 minus 1 over 3, which gives you what? 9 times 3, it is 27, minus 1, 26 over what? 3. And 26 there goes 8 times, and then the 2 over 3. Okay, so notice that is our final answer. When we're dealing with definite integrals, we find a value. Okay, so we find a value. And also one thing that you should notice is that the c's always cancel. So when you're integrating definite integrals, you can omit the c. This can omit, you should actually omit the c. Let's see this in the next example. Find the integral of 1 to 2 from 1 to 2 of 3x squared dx. Okay, so we have a 3 which is a constant. We can take it outside. 1 to 2 of x squared dx. Okay, so again, we integrate that. We have 3 multiplied by x to the power 3 over 3. Okay, so now we are not going to put a c. We just put the limits 1 and 2. But this 3 cancels. The 3 cancels with that 3. So you just remain with x to the power 3. So let's replace. This gives us, where there's x, we first replace with 2. So 2 to the power 3 minus, we replace with 1. 1 to the power 3. So this gives us 8 minus 1, 7. Okay, so whenever we are introducing definite integrals, we have to talk about one thing that we need to know is that actually this just explains the fundamental theorem of calculus. Okay, so it's simply what we have been doing, but we'll put it in terms of the theorem. Okay, so the fundamental theorem of calculus just states that suppose f is a function on the interval a comma b, so that is a and b being our limits, and f of x is the integral of the small f. So you have capital F being the integral of the function f, Then the integral from a to b of the small f dx is just the integral replaced by b minus the integral replaced by x, which also just means f of x from a to b. Okay, and that's what we have been doing. Okay, so now we move to something else called the area. Okay, so finding the area is actually an application of integration. Suppose we have a function, a graph. Here, x is a, and there x is b. And this is the function y is equals to f of x. Of course, this is the y, and that is the x. And this, given that this is our region A, how can we find the area of that region? So, of course, we have let the function f of x to be y. Then, area of the region A is just given by the integral from a to b of y dx. And what is our y? It is our f of x. What you have to notice is that a and b are x coordinates and y is our function. Okay, now if we had another case where we have something like this, and you have the y is a, y is b, and now this function is x is equals to f of y because it is along the y, and that is our region. Then the area of region B is just equal to A to B of x dy. Now we are differentiating with respect to y. Okay, this is just the same as a, b, f of y, dy. Okay, so that is how we find the area. Okay. Let's have some examples. Okay, so let's have some examples. The first one, Find the area bounded by the curve y squared is equal to 8x. The x-axis and the line x is equal to 2. So, as you can see, that is why it was very important for us to know how to sketch, because you need to know the region, you need to identify the region. So, we sketch. So, in this case, please make the box for y squared is equal to x squared. Write it here. So this is our line. Remember that this is a y squared is equal to x squared, so it's not a straight line. It is a curve. Goes there. And we have a 2. So x is equal to 2. Remember, this is the line that is parallel to the y-axis. Okay. And what is the x-axis? The x-axis is there. So it is the region between the x-axis, x is equal to 2, and this curve, y squared is equal to 8x. So this is our region A. Now here we have a 0. So to find the area, you need the points, 2 points of x and the y curve. Okay. But remember, so let's put the formula first. So area is equal to the 2 points of x, y, dx. Okay. So we can get the 2 points, 0 and 2. And the y curve. But here we don't just have a y, we have y squared. So we change this y squared is equal to x squared, 8x, to just y. We just want something like y is equal to. So what are we going to do? We square root everything, both sides. We remember the y is equal to square root of 8x. So this is the function that we use. Okay, so the root is for everything. Okay, so this is the function that we're going to put the square root of 8x dx. Okay, now we can solve. So let's solve now. Root of 8. So according to, we can separate square root of 8 multiplied by square root of x dx. Square root of x is a constant, so we can take it out. So we have square root of 8 outside and root of x dx. But what is root of x? Just the same as x to the power half, right? So we have outside, we have root of 8 integral from 0 to 2, or what? X to the power half dx. Now that it has been simplified that way, okay. Now that it has been simplified that way, then we can have what? We can now integrate because it looks like one of the standard or important results. So we have root of 8 outside. Then we put our x half plus 1 over half plus 1 plus what? 6. But remember, these are definite integrals, so we omit the c and we just put the line and we have 0 0 to 2. Then that gives us what? Root of 8 x to the power what? X to the power is 3 over 2 over 3 over 2. Okay, but these values do not have x, so we can as well just take them out. But remember, this is divided by 3 divided by 2, so we can change them and have the 2 there. Root of 8 over 3 x to the power 3 over 2 0 2. Okay, so we have a 2 there. Okay, so we have a 2 there, but this is a bit let me just write everything nicely down here. So that will give us 2 root of 8 over 3 x to the power 3 over 2 0 2. Replace. So we keep these which are not changing. When we put 2 there, then we get okay, so then we get square root of 2 to the power. Okay, so this will give us, when we put 2 there, we have 2 to the power 3, and when we put 0 there, we'll have a 0. Okay. And remember, okay, can you simplify from the roots of indices? You have root of 8 and square root of 2, 3 over 3. Over 3. Okay, when you simplify, this should give you 16 over 3. So area is given in square units. It's units. So you have to put at the end your answer 16 over 3 square units. Okay, so that is on the first example. Please do the simplifications Okay, so now we move to the next example. In the next example, we need to find the area bounded by the curve. So we have the curve y is equals to 4x squared, the x-axis and the coordinates x is equal to 2 and x is equals to 3. Okay, so the first thing is to sketch. Y is equals to 4x squared. This is the line there. X is equal to 2. We can have x equal to 2 down there and 3. So this is the area between x, between x is equals to 2 and 3, this graph and the x-axis. Okay, so what is our area? We need 2 points of x, which are 2 and 3, y function dx. So the y is that y is equals to 4x squared. So then we have the integral from 2 to 3 of 4x squared dx. Integrate that. We take the 4 out. 2, 3, x squared dx. And this would be 4 x to the power 3 over 3. So put the ones that are not changing outside. Actually, we need to put the limits as well. Okay, so sometimes I'm putting the slash, sometimes I'm putting the square brackets. All those can be used to put the limits. Okay, so then we have 2 to 3. So we have 4 over 3, not changing. Then we say, when we put 3 there, we'll have 3 to the power 3 minus. When we put 2, we'll have 2 to the power 3. And that gives us, when we do everything, we'll have 76 over 3 square units. Okay. So sometimes you find in the tutorial sheet, we have the x coordinate is given a special name known as ordinate, and the y coordinate is known as axis. Okay, so those are the terms that you're going to find in the tutorial sheet. Okay. Okay, so we have an exercise. We have an exercise. Find the area. Find the area bounded by the curve y is equals to 4x squared and the y-axis with abscissa. So that just means the y coordinate. Y is equals to 2 and y is equals to 4. So the curve is given by that. So this is your 2, that's your 4. This is the region that you're looking for. So this is our y equals to 4x squared. Now, this is a case where you have 2 points of y. So you need an x function. So you have to convert that into, change the subject of the formula to x, because your area should be given by the 2 points of y, which are 2 and 4, x dy. Okay. So please solve. Okay, so we now remain with the second part of applications of integration. So for now, we'll end here. Thank you.